Hello everybody and welcome to the Homework Helper for Statistics number 5. When we start this section, we're looking at contrasting association and causation. What this section says is when collecting data, statisticians are often interested in making predictions. Sometimes they can simply want to know if one variable is related or associated with another variable. So can you predict one variable given information about the other one? Other times they want to determine if one variable actually causes a change in another variable. So for example, for each example below, decide whether the variables simply explain each other or if you think one variable would cause the other to change, okay? So some things just happen side by side, and so if one's happening, you can predict that the other is happening, but some actually cause change in the others, and so we're gonna try to figure out what those are. So when we look at something like this, number one, the amount of food Ollie the elephant eats increases her weight, as the amount of food Ollie the elephant eats increases, her weight also increases. Is the eating of food a cause of her weight, or is her weight a cause of her eating food, or do they just so happen to associate at the same time? I think we can say that's going to be a cause and effect, okay? As popsicle sales go up in the summer, the number of people drowning also increases. So do popsicles cause drowning? Does drowning cause popsicles? Or do they both arise from a common cause, that it's warm? So we would say that those are associated. So that's what you want to look at for that ready section. Okay, let's go ahead and go to the set. Shoop. Okay, so we're going to identify population, sample, and parameter. This is just like the in-class section. So for each one, we're going to look, see what the larger population is, see what the sample we're taking is, and then figure out the parameter of interest. What do we actually want to know? So for number 5, the local school board wants to get parents involved to evaluate teachers. They select 100 parents and find that 89% approve of their child's teacher. So what's the population? Parents of students. What's the sample? Looks like they picked 100 of them. And what's the parameter? If they approve, if they want approval of teachers. I would kill for 89%. Okay, let's go to number 6 here. Janet wants to know the average height of the students in his school. There are 753 students in his school. He finds the height of 52 of them. Population, students, 753 students. Look how specific this is. Sample, 52 students. And parameter of interest, height. Okay, easy peasy from there on out. Let's go ahead and go to the back side. Zip, zip, zip. For each scenario, we want to identify what type of sampling was used to obtain the sample and explain whether or not you think the sample will be representative of the population it was sampled from. So this refers back to the class lesson where we looked at this thing here, right? We had you're in charge of school activities and we want to know, and there were all these different ways. And it's worth giving some vocabulary to each of these sections. I mean, last time we may have just read over them just to kind of understand what's alike and what's different. But for our first one, A, this is called a simple random sample. When we reach into the bowl, when we pull out a name, simple random sample. For B, when we pick a number and then do every 10 or every whatever, that's a systematic random sample. For C, when we break it up into groups and then pick 2 random people from that, that's called a stratified random sample. For D, when we break it up and then just fully pull those areas that we broke up, that's called a cluster random sample. For E, when we're in the comments asking people what they think, that's a convenience random sample. And then for F, where we leave the flyers on the table, that's called a volunteer sample. And the volunteer sample, you can see that it misses a key word that all the other ones have, and that word is random. The volunteer sample isn't necessarily a random sample. Okay, so now that we have this vocabulary, we need to look at each of these. So number 8 here. Elvira surveys the first 60 students in the lunch line to determine if students at the school are satisfied with school lunch. So what type of sample is this? If this is her first if she's questioning the first 60, that's not a simple random sample. It's not a random number. It's not systematic. We're not counting by tens. It's not stratified. We're not breaking it up. This is just going to be a convenience sample. Because it's what's in front. It's a convenience random sample. And is this going to be representative? And probably not. We would say no. And why not? We have to explain. Why would this not be a representative sample? Well, the first people, why are they the first people? There might be extenuating circumstances that cause them to be first. Circumstances cause them to be first. And you can also imagine, like at some schools, they have first lunch, second lunch. At our school, the first 60 people would be, Ryan, because he lets his class out early, that sort of thing. So, yes, this may not necessarily be a representative. Okay, let's look at number 9 here. Elvira selects every 5th student in the lunch line to determine if students at the school are satisfied with the school lunch. What type of sample is this? So when we're counting 1 by 1 by 1, that's going to be our systematic random sample, okay? You assign each student in the school a number, you randomly select starting at the first 10 numbers, and then select every 10th student, blah, 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 blah. That's what this one's going to be. This is going to be systematic random. Okay, and et cetera, et cetera. So for all of them, just go through, look at it, and then when it asks you the representative question, is this systematic random sample going to be representative? Yeah, probably. Yeah. All classes, whether the teachers let them out early or hold them late, will be counted. Yeah, everyone's represented. Okay, so that's it. That's all we got to do. The hard part is just the vocabulary piece, making sure that you're connecting each type with what it's actually called. You can kind of see it all in the video there. There we go. Remember, we got our simple for when we're reaching in and grabbing at random, systematic when we're counting every 10 or so forth, stratified when we break up the groups but then take a random sample from those groups, cluster when we break up the groups but then fully pull some of those groups, convenience when we're just asking who's in front of us, and volunteer if we just let people answer as they will. All right, that'll do it. Have a good time doing this homework.